Okay, so let's start our next part of section 3.1. And we're going to look at tangent and cotangent. But first, let's start with tangent. So think of what tangent is. Tangent is the same thing as b over a when we have our points a, b. So go ahead, let's look at the unit circle. So remember, this is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. Remember, this is 0, 2 pi. This is going to be pi over 2. This is going to be pi. And this is going to be 3 pi over 2. Okay, so think about this. If this is b over a, what do you notice? What does y equal when the tangent of x is 0, pi, negative pi, 2 pi, or negative 2 pi, or some form of those? What does y equal tangent x equal? Well, if I take the tangent of 0, so this would be 0, I would get 0 over 1, since it's b over a. So I would get 0 over 1, which would be 0. Alright, what about pi? I would get 0 over negative 1, which would be 0. If you were doing your t-chart here and trying to keep up with this, if I found the tangent of 0, I would get 0. If I found the tangent of pi, that's b over a, 0 over negative 1 is 0. What about negative pi? Now this is going in the other direction here, but we still end up at the same point, negative 1, 0. So that's still going to be 0. And guess what? 2 pi, you're 0. And at negative 2 pi, you're 0. Now, what does this mean? Well, what happens when a y coordinate is 0? This is our x-intercepts of our graph. This is the x-intercepts of our graph. Well, what happens then so notice what we're doing. All you're doing is some kind of function of these 2 points. This is 0. This is 2 pi. The same point is 0 and 2 pi. Well, it's also negative 2 pi, because if we went around this circle, back around, we would still be at that same point. So we're just oscillating between these 2 points. So the x-intercept is going to be some form of pi. So how would we write that in general form? Well, we would say that the x-intercept is x equals k pi, where where k is an integer. So k could be 0, 1, 2, 3, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. It could be negative 1, negative 2 pi, negative 3 pi. So any form of pi is an x-intercept, is basically what I'm telling you here. Any form of pi. This would be the general equation for all the x-intercepts throughout a tangent function. Okay, throughout a tangent function. Well, what about if that happens at the x-intercepts, what happens at pi over 2, 3 pi over 2, and the negatives of those? Well, think of it this way. Tangent is still b over a. So if you draw your t-chart and we look at pi over 2 and 3 pi over 2, what's happening? Well, it's b over a. So at pi over 2, that's going to be 1 over 0, which is undefined. Undefined. At negative 3, at 3 pi over 2, that's going to be negative 1 over 0, which is undefined. Well, guess what happens if you go to negative pi over 2 or negative 3 pi over 2? What is that doing? Well, it's still going to be undefined. Still going to be undefined. So what we say is this. At the points of pi over 2, 3 pi over 2, or any of their forms, we have a undefined function, which is going to leave us with what we call a vertical asymptote in the graph. So it's going to leave us with this vertical asymptote at that point in the graph, which means our graph will never pass that vertical asymptote. Well, what's the general form of this, of the vertical asymptotes? Well, the vertical asymptotes are going to be everywhere it's pi over 2 or a form of pi over 2. Now notice, when I say a form of pi over 2, look what we're doing. We're going, it's either going to be here when we end up here, or here, or one of these forms of these 2 points. So how far are we going around the circle? Well, we're making the semicircle, right? What is that distance? That distance is pi. So what we would say is that the general form is pi over 2 plus k pi for the vertical asymptotes. And you can just write VA for the vertical asymptotes. So at every version of pi over 2 plus any version of pi, at pi over 2 plus any version of pi forms of that, you will have a vertical asymptote. So at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and the negatives of those, you would all have vertical asymptotes at those points, okay? Vertical asymptotes at those points. So what does that mean for pi? Well, now what does that mean for tangent? Well, let's look at the graph of tangent. Because if you have tangent here, zero, pi over 2, pi, 3 pi over 2, 2 pi, and let's go in the other direction. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Well, what do I know? Well, here's what I know, okay? I know for a fact that I have x-intercepts at every version of pi, at every integer multiple of pi. So I know every single one of those points there are intercepts. I know that I have vertical asymptotes at pi over 2 and any multiple of pi over 2, of any multiple pi of pi over 2. So, in other words, when I say multiple pi, it's hard to describe that without showing it to you. At pi over 2 plus any pi multiple of that. I hope that makes sense now that I've written it out. You have a vertical asymptote. So that means I would have a vertical asymptote here. I would have a vertical asymptote here. A vertical asymptote here. Excuse me, I drew that in the wrong spot. I'm sorry. A vertical asymptote here and a vertical asymptote here. Okay, so we have vertical asymptotes at those spots. So I know my graph is going to occur in between those dotted lines, basically. Well, how do we figure that out? Well, we need to figure out one that we know, okay? So figure out some points that you know in here. This is where you have to go back to your good old-fashioned algebra. Those of you that love algebra, here we go. We know the x-intercepts. So there's no reason for you to try to find out what 0 and pi over 2 and 3 pi over 2 are. You're going to have to find out some of these intermediary points in here. So let's find out one that we know. Like for instance, I know this point right here is pi over 4. I know this point right here is negative pi over 4. This one is pi over 4. Okay, pi over 4, negative pi over 4. So what is the tangent of pi over 4? Well, remember what pi over 4 is. Pi over 4 is the 45-degree angle, which should have these 2 points, 1 over the square root of 2, 1 over the square root of 2 for pi over 4. So if I were to, tangent is b over a, this would be my b, this would be my a. So if tangent's b over a, if I divide those, what do I get? I get 1. I get 1. Well, what happens if I look at negative pi over 4? Well, think of your unit circle first. Negative pi over 4 is going to be right here. It's going to occur in that quadrant. So the x value is still positive, but the y value in quadrant 4 is going to be negative. So when I divide these two, instead of getting 1, I get, you got it, negative 1. I get negative 1. Okay, so what does that tell me? Well, that tells me at pi over 4, I'm up here at 1. At negative pi over 4, I'm down here at negative 1. So my graph looks something like this. Now, the closer we get to those dotted lines, the more we go toward positive and negative infinity. So your graph should look something like this. And there's a really good drawing of it in your book, better than what I'm going to be able to replicate here at the bottom of page 129. Now, because tangent is a periodic function, we can say that all of these are going to look like this. So if you label, this was pi over 4, this would be 3 pi over 4. Pi is 4 pi over 4, so this would be 5 pi over 4. So I know at 3 pi over 4, tangent's going to be negative 1 again. And I know at 5 pi over 4, tangent is going to be positive 1 again. So my graph looks something like this again. So at every one of these, you're going to get a drawing that looks something like this. So this would be the drawing of our tangent function. Something similar to this. Now, there's a good drawing of it, like I said, on page 129. But this would be our tangent function. This would be our tangent function. Now, what can we say about the tangent function? Well, what is the domain? The domain is all real numbers except all real numbers except the ones that make the vertical asymptotes. So all real numbers except where x equals a vertical asymptote. That's going to be the domain. All real numbers except where x equals a vertical asymptote. Now, the range is all real numbers, because notice our arrows north and south go from negative infinity to infinity. So the range is going to be all real numbers. It's the domain that's not all real numbers here. Now, here's my question for you, and this is the most important one. What is the period of this graph? What is the period? Well, so in other words, I'm going to know what this distance between these vertical asymptotes is. That would be the period. This distance between each of these vertical asymptotes should be the same. So what is that distance? Well, think about what we're doing here. We're going from negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2. If you look at the middle here. If I'm looking right here at the middle, this is the very first one we graphed. Okay? This is the very first one we graphed. So when you're making a tangent graph, and your period is pi, remember. The period's going to be pi. How did I get that? How did I get the period to be pi? Well, think about it. The distance from negative pi over 2 to 0 is pi over 2. Add to that the distance from 0 to pi over 2, which is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi. So that's how I got that period to be pi. The distance from negative pi over 2 to 0 added with the distance from 0 to pi over 2. So when you're drawing a tangent graph, you don't want to do like we did with sine and cosine. If you remember at sine and cosine, we started out and went from 0 to 2 pi because it's pretty standard. Well, because of these vertical asymptotes, you've got to know that the vertical asymptotes at tangent occur at the pi over 2's and 3 pi over 2's and 5 pi over 2's and things like that. So you're going to want to make sure and adjust your graph so that your graph starts at, say, negative pi over 2 and goes to pi over 2, because that's one period. If I want your graph to go 2 periods, you would start at negative pi over 2 and you would go to 3 pi over 2. This would be negative pi over 2 to 3 pi over 2 is what we would call 2 periods, because that would be 2 pi's there, because one period is pi. Okay, I hope this makes sense. This is one of those topics that you really gonna have to study. This is because I'm gonna expect you, if I write y equals tangent x on test, I'm gonna expect you to be able to graph that for me. Okay, so keep that in mind. And you can always come by and see me if you have questions. All right, well, now that we know tangent, believe it or not, now that we know tangent, we can find cotangent. Because what is cotangent? Think about that. Think about that. We know tangent. Cotangent is the reciprocal of tangent. So cotangent is the reciprocal of tangent. Well, that tells us a lot of stuff. We know with the tangent function, we know that any version of pi is an x-intercept. We know that any pi version of pi over 2, any pi version of pi over 2 is a vertical asymptote, or it's undefined. That's what we know about the tangent function. Well, think about this. In order for this to be an x-intercept, this is 0 over some number, like 1 or negative 1. In order for these to be vertical asymptotes, if you remember, these all ended up 1 over 0, which made them undefined, or negative 1 over 0, which made them undefined. That's how we came up with the x-intercepts and the vertical asymptotes on the last slide with the t-chart, if you remember. Well, if cotangent is the reciprocal of tangent, what does that mean about cotangent? At these same points, cotangent x, at these same points, k pi, and at k pi, and at pi over 2 plus k pi, these would be the same points. What happens now? What happens now? Well, actually, what is going to happen now is that the vertical asymptotes will now be flipped, and they will actually become the x-intercepts. The x-intercepts with cotangent will actually become the vertical asymptote. Now, why does that happen? Does anybody know? Well, it happens because the vertical asymptotes, the fractions that give you the vertical asymptotes, the fractions like right here, these two fractions, these fractions that give you the x-intercepts and that give you the vertical asymptotes are now flipped because we're doing the reciprocal with cotangent. So if you flip 0 over 1, you get 1 over 0, which is now undefined. If you flip 1 over 0, you get 0 over 1, which is now 0. So they're actually flipped from each other. Now this is very interesting because this makes cotangent, if you know what tangent looks like, this makes cotangent fairly easy for you to draw here. Okay? Makes it fairly easy for you to draw. So this is 0, pi over 2, pi, 3 pi over 2, 2 pi, and this would be negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So with that being the case, if I know what I know about the vertical asymptotes and tangents being flipped now, that means I know every version of pi is a vertical asymptote for cotangent. So I know all of these are now, with cotangent, they go from being x-intercepts like they were with tangent to being vertical asymptotes with cotangent. On the other hand, the vertical asymptotes that we had with tangent now go to being x-intercepts. Okay? Now, notice how we're going to have to adjust our graph. Notice the period of this graph. What is the period here? Well, just like tangent, what is the period? Just like tangent, the period is pi. Because look at the distance between our asymptotes here. It's going pi units every time. But notice how our graph has shifted because our asymptotes occurred at negative pi over 2 and pi over 2 with tangent. Now they're occurring right on the pi's. So it's caused us to have to shift our asymptotes. So even though we still have the same period, they're on nice round numbers like 0, pi, 2 pi. They're not on the pi over 2's like they were before. So here's where you've got to be careful because now what we've got to do is we've got to determine other points. So what is a point that we know very easily we could take the cotangent of between 0 and pi over 2? Well, that's pi over 4. This would be 3 pi over 4. So if you go back make your t-chart, and we want to know what cotangent of pi over 4 is, and 3 pi over 4. Well, we already said that the tangent of pi over 4 was 1. So cotangent is just going to be the reciprocal. So when I take the reciprocal of 1, I get, of course, 1. Well, 3 pi over 4, we said the tangent of 3 pi over 4 would be negative 1. Well, when I take the reciprocal of negative 1, I just get negative 1. So that means I have this right here. So if I plot those 2 points, I can now draw my graph and look at what happens. Look at how my graph looks now. So this would be our period. From here to here would be a pi. So cotangent occurs over the course of that period. And notice, instead of rising, this is decreasing across the period. So it's a little different from tangent in that it's decreasing instead of increasing. But just like tangent, it's going to occur the same way at each of our periods. Just like tangent, okay? And there's a great drawing of this one as well on page 130 in your book. So be able to graph tangent and cotangent. I hope this made it at least understandable for you, okay? The next one we're going to come up with will be cosecant and secant, and we'll be done with the basic graphs at that point.